good morning everyone. My name's Stephen Cooper. I'm with Juniper AI Driven Enterprise all the way from Australia, and I'm going to use this missed opportunity to talk to you about roaming and hopefully answer why did the zebra cross the road. By road, I probably mean aisle in a warehouse, and I could have named this after Wherever I May Roam, a famous Metallica song, so if there's some metalheads in here, I'm sure you'll get the joke. So how do we understand and troubleshoot device roaming? How do we get into the green diamonds of what people and devices choose to roam to which APs? You know, AP1 could be negative 63 dBm, AP2 could be negative 69 dBm. Why not just roam to the weaker one, right? So how do we understand this and get better visibility of what decisions devices are making? And the traditional way of troubleshooting roaming, as I'm sure a lot of you are familiar with from your histories and working in Wi-Fi and troubleshooting, is a lot of processes, a lot of manual tasks of data collection and analysis. So we have surveying, multiple packet capture cards, we have understanding and analyzing protocol analysis and Wireshark captures. We have looking at syslogs and live debugs as we're trying to see what's happening on the control plane as devices roam through the network. And most importantly, what are the users complaining about? They're complaining about their poor application experiences as they have poor roaming experiences throughout the network. So how can we make this better? You know, first and foremost, we want to get better visibility of what's happening on the infrastructure side, so we can actually gather a lot of additional telemetry through your existing infrastructure or even different infrastructure. There's about 150 different things that can go wrong with users connecting to and consuming Wi-Fi. Roaming is one big piece of that. Gather the client-side telemetry data, which could be from a smartphone agent, it could be from an SDK. If you're running Hamina Wi-Fi, maybe it's from a walrus telling you that the roaming is bad. But you can also then start to gather all this data together and then automate that root cause analysis process. How do you define, is it the network that is to blame for the bad roaming experience, or is it the device itself that has made the bad roaming experience happen? And so machine learning plays a big part in that, as well as then improving the visualization and understanding of this to make it easier for not only us as experts and people that have been doing this for a long time, but also people in lower levels of IT can start to understand this better and help assist with troubleshooting. And then lastly, to make it even easier than that, is just completely abstract all of the complexity from this and make it really easy to troubleshoot application experience problems. So artificial intelligence operations does require a lot of data science, and this is just some of the examples of what the Mist AI team and Bob Friday has been doing since the inception of Mist, and a lot of other vendors out there are looking to do very similar things. We've seen some talks today already this week, about some use cases for solving some of these problems using deep learning and neural networks and making it really easy for us to troubleshoot these problems. So what are the benefits of getting this structured data, improved visibility from both the infrastructure side and the client side of the experience? Is we can now get this data over time. We can gather information not just as a reactive measure, but as a proactive measure and have access to this data. We can then start to see when there's been greater problems related to latency, stability, signal quality over different periods of time. It also means that we don't necessarily need to get users involved with the troubleshooting process. We have the data of when things were good versus when things were bad. And we can then start to distill what roaming related problems are the client's fault versus the infrastructure's fault. Is there a bad Wi-Fi design? Do you have some misconfigured settings on your SSIDs? Is the client just choosing not to roam? And so we have examples of where we've got clients that are failing to fast roam, even though they're capable of 8 to 11R fast transition. And then we have clients that are just truly sticky on the network. There might be a better access point to roam to, they just choose to hold on for dear life to that one. The machine learning aspect, the AI ops and the data science then starts to help us prove that mean time to innocence of the network, and is it actually a device-related issue or an RF-related issue? So this is where we can do some feature analysis and say, well, look, you know what? There are some roaming issues, but it's only on one particular SSID or wireless LAN. So you shouldn't be expecting everyone to be complaining about this. So you're getting some additional context of who's actually having a problem. We can then even say, based on some profiling of device types, we know Apple users are having a bad time with roaming at the moment. You shouldn't expect to see people complaining about roaming on your Android devices. We just don't have that correlation there. And lastly, we can say, well, these particular access points are having problems. So you can draw location context into where people are having roaming problems across the network. So visualizing this is a lot cleaner to view. You know, when things happen, you can have all sorts of different, red, amber, green thresholds. You can set these up and say, well, what's your target for success? What sort of roaming and coverage success do we want to guarantee for our clients? And this is sort of, analogous to what you'd be looking at on a syslog and trying to determine, what's happening from a client roaming from APA to APB. How do we make that even easier to look at? We're very visual people. We like to see things over a time frame period and start to see, okay, how has the device's life cycle as they've traveled throughout a facility or an environment actually had a good or bad roaming experience? Even better than that, we can replay this. We can actually say, what was the path of the client that was taking as it went through the facility, and where were these good or bad roams happening? And we've got the data there to say, both on the infrastructure side and the client side, what has actually gone wrong. This is where we get deeper into this client level. Obviously, there's different solutions out there in the market for client level visibility. We've seen some good presentations this week from this. And again, how can we use this beyond just Wi-Fi? This is a great example of getting telemetry from Zebra devices where we can actually see whether they've roamed outside of Wi-Fi coverage and started to roam into cellular. Cellular might not be your problem. So why would you actually be helping someone to investigate a bad roaming issue if they're not even on your Wi-Fi network? So it is really critical to get that level of visibility. Once we start to go into this device level visibility, we can start to see what decisions these devices have made, independent of how good our Wi-Fi network might be. And then we can start to say, well, what's actually happening at this point in time? When these users have reported call dropouts or voice call dropouts or service dropouts, we've got the data here now to back it up and say, well, you know what? It was or it wasn't a roaming problem. Not only that, we're getting the client's perspective of how they see the RF neighborship. Not just the APs on the ceilings and how they see each other, but how the clients are actually getting this from, 8 to 11 KR and V and what their neighbor tables will say. So we can see, if they had the information there, why did they not choose to roam to a better access point? Not only that, getting deeper into that application level side of things. And this brings me back to Zebra. And we're not the only ones that integrate with Zebra. There's a lot of great integrations out there as well. But it's just to give you some example of tying in that roaming experience into application quality experience, such as voice call, VoIP link qualities, and those sorts of things dropping out as well. So this is all well and good. This is really great deep level stuff. It's been automated. We no longer have to do manual packet captures. The system's already set up to do that for each and every user across the entire network. It scales dynamically. The data is there if we need to dive deep into it and just validate exactly what the AI and machine learning algorithms have actually been proving to us and say, yes, this is really a problem. Someone's complained about this and this is what the problem is. So then we can get to improving that service and actually solve that problem better than we have before. But really, not all roaming problems are equal. Not all roaming problems are Wi-Fi problems. And to prove that, this is where we bring this view across just not the Wi-Fi network, but going into switching, going into WAN performance, as well as application experience performance. Because really, when your users and your customers are actually complaining about roaming issues, they're never going to come to you and say, oh, could you help me troubleshoot this area of the building? I didn't roam from AP1 to AP2. You need to take a look at that. They're going to come to you and say, look, my Teams call dropped out. I can't tell you exactly when that was. Maybe it was sometime in the last week, but I need you to fix it. And so the IT team, the service desk, first level triaging, what are they going to do? Traditionally, they would just bump that up to the level 3 network engineering team, and it's all your fault to fix, right? But this is where AI in action can actually help things get better. You can help service desk team members and lower level staff members to troubleshoot user experience problems, not just networking problems, not just switching problems. We can say, Randy, he's complaining of a bad Teams call. Roughly in the last 7 days, maybe it was on Tuesday, he couldn't tell us exactly when it was, but it doesn't matter. We have the data there. We have all of Randy's Teams sessions there. We can investigate it. And the system will show, okay, Randy's device was actually having some bad problems. We could actually click into that and see Randy had some failed fast roaming events on a couple of APs. So in this instance, we have the proof. Absolutely, Randy was having some roaming problems, but it wasn't necessarily the network. We can then go into another session there and say, well, okay, there's multiple sessions here. Which one is Randy complaining about? Sticky client behavior. So multiple roaming issues, different times of the day, same client, it can be to blame for multiple reasons. And in this particular instance, Randy's MacBook was all good. There was no problems with Randy's MacBook, but we can actually validate that there was high network latency impacting the Teams application. So in this particular instance, it was not a Wi-Fi roaming problem whatsoever, but Randy was complaining of a bad Teams call. We have the proof here that across the network stack, it was impacting his experience. We can then now focus on the WAN and improve his end user experience overall. So thank you very much for that. I hope that was useful. Thank you.